Welcome back to part 2 of the Mach plugin wizard XYZ tutorial. In this part we will take a pretty well line-by-line look at machdevice.h and machdevice.cpp. Those are what I call the shims between Mach and our source code that we'll implement in plugin, and they provide the entry points. Let's start up our compiler. We'll click on our XYZ recent project. It will load it. We'll bring out the Solution Explorer and we'll look at the machdevice.h first. This header only has 2 lines that you might want to come in and edit, but you don't even have to do that because the tutorial kind of does it. The wizard does it for you as it generates the file. The Pragma once is a standard line used by include files, so that they only get included once within a given program. The 2 lines that are significant here is this define of PI plugin CPP. By having this defined, and if you wanted to undefine it, you would comment it out. By having this defined, you are telling Mach device CPP, you're telling the compiler in essence, that the PI plugin, that the plugin CPP and H files will be used to control access to the extra modules that you've added. The second line sets a default plugin name that is used in case you have not implemented the PI, I'll start pronouncing that pi, the pi set pro name. We'll see that as we get into the details. The rest of the file sets up the includes of the Mach data structures that are needed. Now, the way I set up the includes in this environment is I include a file, and then if it needs files, it includes those files. This replaces, as you've seen in previous SDKs, where you might have seen a whole bunch of files and then seen engine and trajectory control. Now, a note about this underscore for trajectory control and Mach view. I consider that to be the word not. Underscore trajectory control to me means not trajectory control. And what I'm trying to tell you here is this is not the trajectory control that was provided in the SDK. In the case of engine and RS-274, it also is not the trajectory, the H's, but the changes were just cosmetic. There wasn't any, they were already structures. We'll go into a couple of the H's in the future tutorials, and you'll see why they're different and what the differences are. But again, you don't have to touch these. These are how they work. This code is pretty well straight out of the original SDK. Mach is going to provide us with a bunch of pointers to the functions that we can call inside of Mach. This is the way to give us access to get draw, set draw, get LED, those type of functions. And actually, as you'll see in the code, we call them as if they're one of our functions. If you don't look at the details of the pointer and the source code and all that type of stuff, you might go searching for a function called getDraw somewhere in this plugin because it looks like we're calling a function. But what we're really doing is using a pointer to a function, and the compiler takes care of all the magic for us. So these are the type defs that are necessary for that magic. Now, in the programming world of C, we talk about externals versus a defined variable. In Mach device, we will actually declare or instantiate or give life to these variables: do button, get menu range, get draw, set draw, etc. But any other module within our plugin, if they want to use these variables, all they have to do is include machdevice.h, and by this declaring it as an external, at link time the linker will find what other module has the variable. If for some reason you have deleted one of the variables in Mach device, can't think of a reason you would have done that, at link time you'll get an error saying undefined global, that I can't find this external. So again, you can leave these alone. They're pretty well here just for your use to manipulate. Profile name is a character pointer that will contain a copy of the full path of your XML file that is currently being executed. You can store your plugin data in that XML file if you choose. You could also store your plugin data in its own XML file, but it would then be up to you to make a full path by looking at some other variables in the Mach headers. Then finally, the 4 important pointers, which are the engine setup, main planner, and Mach view, and those names remain the same. You'll see here they had used a underscore setup because the type def was for a setup, but they wanted to have a variable which was called setup. You'll notice that we still kept the same names, so all of your code should be transparent, but of course we are mapping them as pointers to structures instead of pointers to classes. That's it. That's the end of mockdevice.h. I'll go ahead and leave that open. Actually, let me do a Control-S and save it so the asterisk goes away, but I really hadn't done any changes to it. I put those comments in and then took them back out. Mach device CPP is the real workhorse of connecting you to Mach, or actually Mach connecting to you. When Mach finds a DLL living in the Mach 3 plugins directory, it executes probably a few hundred lines of code that go out and examine the catalog or table of contents of the DLL and tries to load a bunch of different functions from the DLL. And if it can't find those, you get an error message saying ill-formed or malformed DLL being skipped or whatever. The functions that must be exported are in this file. Please read all these notes here at the header. It's in there for your education. Now, the first thing we do is include our standard AFX to get in the headers for Windows functions, and in the case of MFC, it'll bring in MFC functions. The next, we bring in our Mach device.h, and that will bring in all the other H's that we need to make us happy. The next 3 lines are an if-def. If in the Mach device H we have told it that we are going to use plugin CPP, it will assume that there's going to be a plugin.h. But again, this is optional, although by default pretty well all of the plugins that the wizard creates will have this turned on. Okay. Extra includes area. If you were going to do your development right here in Mach device, you might put in other includes for other functions, screens, XML, all this type of stuff. Again, we recommend doing all of this over in plugin CPP, and don't recommend that you ever look at Mach device again. Once you've learned how it works, it'll just be there. It'll work like magic. It's what I call a shim between you and Mach, and you won't have to worry about it. Now, let's cover this managed for a second. It's the only occurrence in mockdevice.cpp. If you are running the compiler with .NET, or the /CLR option as it's called, the compiler can work in either managed or unmanaged mode. And if it's in managed mode, it allows you to use the GCNew and the new style. I can't think of the managed pointers that I'll show you in the next tutorial. But if you're wanting to do just classic code, you say pragma unmanaged. Now, since the rest of this entire program needs to be in classic C++, and it needs to generate true code, not MSIL. We have to, if we're in CLR mode, which is generated by the compiler defining _managed, then we have to give it a pragma saying from here to the end of the file we're generating unmanaged code. Again, you don't have to worry about it. This is all for things behind the scenes. Global variables, remember I showed you all of these as externals over in the H. This is where they're created or are given life, and these are our function pointers, which are all the different functions we can call. And then there is a simple value, which is a char pointer, which is where we make a copy of the profile name that's supplied to us. I made a copy just because I didn't want to take the chance of keeping his pointer and then messing it up sometime by accident. So you'll see that in the shim code in a second. And then the very important, very large objects that are in Mach's data space that have been exposed to us, and that's the engine pointer, the setup pointer, the main planner, and the Mach view, which map to these four structures. That's pretty well all the data up at the top. Now, for the rest of this file, the order that you see the code or the function is the order that I have empirically determined that Mach is currently calling these functions. So the first thing it does when Mach goes out and successfully finds a DLL is it calls set get menu range. Now, honestly, there's no rhyme or reason to why this one's first, in my opinion, but it's first probably because he needed it early in the scheme and it was added near the end of the development of plugin technology. And so since he needed it early, he made it first. And rather than saying, oh, this can be the 7th one, I need it before the 10th one or something like that. It definitely needed to be done before some of the other functions that we're going to use. So because we're going to need this function to use it. Now, you'll notice I try to, in each one, give you documentation about whether or not you can access the XML file, and give you an indication of whether or not this function will be called even if the plugin is disabled. I think I went into this kind of blind, assuming that, oh, if the plugin's disabled, a lot of these functions won't be called. Not true. You'll find that out as you go through the documentation. Now, this Greek is the coding that is required by the compiler to make this a DLL export. Again, don't worry about it. We've done the work for you. Frankly, Art and Brian and John did the work for me, and I just copied it, although at least I understood what they were doing. And you don't have to worry about it. It's all in this shim. It's the only place you'll see this type of Greek is in the shim, and that's the thing. Now, a note here on this first one, on the maybe people think that people were stuttering or double speaking, but you'll notice that it says set get, and you're like, are you setting or you're getting? Well, you could almost put a hyphen in there or an underscore, because what you're doing is you're setting the get menu range variable, and you'll see it in a few minutes that you're setting the set LED or you're setting the get LED. So all of these functions are called set and then the name of the variable that we should be setting. And they pass in a function pointer, and all we do is take that function pointer and store it in the function, in our local function pointer. These type of functions we don't bother to do a pi equivalent of, because it's pretty well down and dirty. Take the function, store it in the global variable, and go home. So there's our set get menu range. And then the next thing that's called is init control. Now, the XML file cannot be accessed because we don't know its name yet. It's actually done in like the 10th item that's called. And this is called even if the plugin is disabled. Now you could instantiate a bunch of variables and create dialogues and things like that, but I wouldn't recommend doing it in here, because if your plugin is not enabled, why waste the system resources? So the important thing, though, that init control is for is this is where they tell us or pass to us the pointers to the 4 very important items. Now they even pass them as a void, because that's how you kind of pass pointers between DLLs, and we will cast those into the pointers that we want: trajectory buffer pointer, setup pointer, not trajectory control pointer, not CMOC view pointer, and then store them in our variables. Now this next set of if, def, else, end, if is the beginning of you seeing the optional call to a pi init control. If the pi header has defined the pi underscore init control, then we will execute or compile a call to the pi init control and return whatever it returns and store it in our bool called start pointer, and then ultimately return start pointer. Now, if we have chosen not to do an init control in our implementation of our plugin, the else will come in, and this would have been grayed out and this would have been dark, and we'll just set the start printer to true and return start printer. That's just later on I'll be just glossing over some of those if defs because we've already gone over it here. Okay, so those 2 are done first. Then it gets back to calling all of our sets. And again, these don't have pi equivalents, so they're really down and dirty and quick. And but even so, though, I let you know that, hey, don't bother trying to access the XML because you don't know what it is yet. And these are all called even if the plugin is disabled. Here's our set do button. Here's our set dro. Here's our set get dro. Here's our set get LED. Here's our set LED. These are in the order he calls. Ends up he calls dro's set get and LED's get set. But I tried to document that they're in the order he calls you. Then we've got one that's called set code. I actually started to change the name of this to do code because I was concerned that the word code could get confused with the compiler as a reserve word. But since it's capitalized, it shouldn't. Maybe in the future we'll change that to do G code or something like that. That's just maybe to protect the innocent and maybe make it more descriptive than just the word code. In a computer program, the word code can mean an awful lot of things. Now finally, and I think it's our last set, is the set that besides setting, it also does some things, and due to what it has provided you, you could, if you chose, at this time, open up the XML file and do some work with it. In my example here, I believe, I went ahead and did that in set pro name. That's pretty well done with a lot of things, but it'll be interesting. We'll find out in a few minutes. But again, because this is called when you're disabled, whether you're enabled or disabled at all, it might still be wise to wait until what's called post init. Well, no, you can't do it in post init control. So I must have done it here. I'm sorry for the babbling, but as I told you in the beginning of one of the others, these are all being done ad hoc. Okay, so you read my notes here, and I let you know what I'm doing, and now let's go through it line by line. Not that many lines, but there will be a lot of lines over in our pi set pro name. The first thing we do is declare a pointer inside of our function that will be used as a return value to return our name. Now the word name may be actually a misnomer. In most cases, it's the name dash the author dash the version number. That's your choice, but that's the style that I'm trying to follow based on how everybody else has been doing it. So the function comes in giving us the long pointer string to a name. And that name is actually the name of the profile path. Maybe I should change that variable, but that's what it's been called in the other shims. Then we create this pointer, and we do a string dupe, which is a C++ function in its primitive functions, doesn't require .NET, and it will call malloc to allocate a new string, and it will copy the string into there. I did this so that we'd have a safe copy in case something changed about the profile, and I didn't want to take a chance of messing with Mach's memory. One of the things you'll have to be concerned as you get deeper into programming is when to free and malloc, and when to use .NET, and when to throw caution to the wind and pass some of those variables back to Mach and worry about memory leaks and things like that. So it can get tight, and so I just felt that by duping this string we'd be safer. Then back to our if-defs, else, and end-ifs, I have declared, because this is solid, this is black, I have declared a set proname, that there'll be a pi set proname, so the compiler includes the call to it. Now it passes the same parameter on to it and gets a return of the pointer that will be our plugin name, and then since the else is false, that is not here. But if you have not implemented a pi set proname, it will by default give you the pi plugin name that you defined in your Mach device.h. That's way you can do a quick and dirty plugin without doing any of the pi set proname and doing XML and all those type of things, but still have an exposed plugin name because you've got to have that. That's it for set proname. Now, the rest of these, I grouped them together for initialization, setup, configuration, and shutdown. These are the, shall we say, plugin maintenance or plugin, what's the word? What state? Yeah, what state they should go into. They should finish their initialization. They should do a configuration. They should do a shutdown. And these are called by Mach at different times. And again, they're in the order they're called. Post init control is called when the startup's pretty well done. And the thing is, you can change and initiate some variables, but you can't access the XML file, or at least according to the notes you can't, and I've copied the notes in. The other thing is, this is called only if the plugin is enabled. But empirically I've found that some of these things are called when the plugin gets enabled, and post init control is not one of those. So you've got to think about that flow in where you declare your variables and define things. So please take a note on where I did them and how I used them for that purpose. In most cases, post init control in the shim will do nothing, and then if you have defined your post init control in your plugin CPP, it will call it. And if you haven't defined it, this will be an empty function in essence. Now, the config in the shim is basically the same idea. The XML file can be accessed. It's called when they press that little button type of a thing in the table, and in most plugins nowadays we either don't do anything, or we come up and say, go somewhere else. And again, if you've implemented that in PyConfig, it gets called. If you haven't implemented it, it gets skipped and nothing else happens. Stop plug is called when it's being shut down, when you close or exit Mach. And this is the good time for you to save your XML back to your profile area, or destroy objects if you're worried about memory leaks. But since the whole program is getting closed down, the objects should be attached to your memory, to your handle for your main window, and Windows should clean it up. And in the case of .NET, the garbage collector will definitely clean up all your objects. So pretty much what most people do in stop plug, besides, of course, maybe stopping a motion of a machine or something like that, is write out their XML. So that's stop plug, and again, if you haven't defined one, nothing gets executed. Now, the meat of your plugin is the 10 Hertz synchronous update loop. Every 1/10 of a second, if your plugin is enabled, this function will be called. Now again, I found out empirically that as soon as you enable the plugin, as soon as you click that little box, this starts getting fired up. So if there are some variables that maybe you haven't instantiated, you'll see some ifs where I protect myself in the plugin sample that we're going to go over in a few minutes, and so you have to be aware of that. Again, in the shim, all you do usually is just call the plugin CPP and call pi update. The next one is notify. Now, notify is used for a bunch of different things in Mach. It sends you messages about starting and stopping and some other items. I haven't gone into those in detail. I haven't done a lot of motion or I/O based plugins yet. I was waiting until I could get it into the Visual Studio 2008 so I could work in the modern environment. The primary purpose I've used this for, and the only purpose that's used in this sample plugin, is the notify that is sent if you click on the menu under plugin control, and then it will send you the ID number that matches that menu ID, and you will based on that open your configuration and configure your plugin. We'll see that over in plugin CPP. Again, same rules. If you don't need it and you haven't defined it, then this will be an empty function. Now, the rest of the functions are called as needed. Now, Art has supplied me with the documentation of what do-dwell does. It was in the Bible that Art wrote, but I had just failed to pick it up, and I will edit that into the next version of the wizard so that it'll be in this documentation. Now you'll notice that this is grayed out. I haven't implemented a do-dwell. I didn't know what it was. I don't need it in my plugin, and so if I don't implement it, then I don't need it. Therefore, there's no reason to waste, if you want to call it waste, another 4 nanoseconds or whatever that it takes to call another function just to have it come back. The same with reset, jog on, jog off. Need to add the comment for jog off. Purge, probe, and home. That's the end of Mach Device CPP. As you can see, Mach Device CPP and its associated H are two files that are very important to the plugin. I mean, there is no doubt these are the focus point of the plugin, but they are a shim that gives most of the work that you want to implement in your plugin over to your plugin CPP file. So you shouldn't need to go through this. You want to go through it for the documentation. You shouldn't need to make any changes to it, but and it'll be generated in every plugin you create. But you just you should understand it. That's the Mach Device CPP and the Mach Device H, and I think that'll end this tutorial. And we'll go over the plugin.h and the plugin CPP, where we'll get into the real work in the next section. Thank you very much.